Azure Network Watcher is a vital monitoring and troubleshooting service that provides real-time insights into your network traffic and infrastructure. Building upon foundational knowledge from previous discussions on Azure Monitor metrics and logs, Network Watcher extends those capabilities to the network layer. By centralizing diagnostic tools, Network Watcher helps administrators identify connectivity issues, packet filtering errors, and anomalies in virtual network configurations. This comprehensive view enables proactive maintenance, ensuring robust operations in cloud environments. With a user-friendly interface in the Azure portal, Network Watcher simplifies the complex tasks of analyzing traffic flows and verifying network security group and SG rules. Whether debugging VPN connections or optimizing routing paths, this service serves as a focal point for continuous network health assessment. By bridging the gap between raw metrics and actionable remediation, it forms an integral component of a holistic Azure monitoring strategy. One of the primary goals of Network Watcher is to simplify the visibility into virtual networks and subnets. Through topology visualizations, you gain a graphical overview of how resources connect, exposing any misconfiguration or bottleneck that might hinder performance. Another critical feature is network security group flow logs, which detail traffic entering or leaving a network interface. These logs, once integrated with Azure Monitor logs, allow robust analytics and alerting based on identified patterns. Additionally, the packet capture tool is crucial for granular debugging. It captures packet data either persistently or on demand for deeper analysis of individual packets. Network Watcher also supports next hop analysis, which reveals the routing path for packets between source and destination endpoints. By leveraging these combined functionalities, administrators can quickly isolate latency issues, identify hops leading to dropped packets, and fine-tune rules to maintain optimal network performance. Deploying Network Watcher typically begins with enabling the service in a specific Azure region. Each Azure region requires its own Network Watcher instance to perform monitoring tasks on the resources within that region. Once initiated, the service automatically discovers virtual networks and subnets, ensuring swift integration. Administrators should carefully manage authentication and role assignments by granting the network contributor role to service principals or user accounts. Additionally, administrators can configure retention policies for diagnostic logs. This helps ensure compliance with organizational data requirements and allows for historical trend analysis. Network Watcher settings are accessible through the Azure portal, Azure CLI, or Azure PowerShell, providing flexibility across different operational environments. By aligning these configurations with organizational best practices, the service can function seamlessly, delivering continuous insights into your network and offering a solid foundation for further monitoring or diagnostic tasks. Network Watcher offers a suite of diagnostic tools designed to simplify network troubleshooting. These include Connection Troubleshoot, which tests the communication path between two endpoints, showing if traffic is allowed or blocked by a network security group configuration. IP Flow Verify helps pinpoint whether a given flow is permitted or denied based on source and destination IP addresses, ports, and protocols. The Packet Capture feature allows administrators to set filters and capture traffic for deeper analysis, either in real time or at scheduled intervals. Another valuable tool is Network Performance Monitor, which leverages telemetry to identify potential latency hotspots or jitter in hybrid networks. These diagnostic aids integrate seamlessly with Azure Monitor logs, ensuring a unified view for alerts and visualizations. Through these capabilities, administrators can address fast-paced demands for troubleshooting and maintain a clear understanding of how traffic moves within and across cloud environments. Connection Monitor is an extension of Network Watcher that focuses on end-to-end network connectivity tracking. It evaluates health by probing traffic between Azure resources, on-premises systems, and external endpoints. This capability is useful for validating the availability and performance of critical applications deployed across a wide network footprint. Operating alongside the broader Azure Monitor suite, Connection Monitor employs synthetic transactions, periodic test signals, to measure latency, packet loss, and throughput. Based on these test results, administrators can create alerts that notify stakeholders whenever the service detects anomalies or decreased performance. Connection Monitor also provides integrated topology views, simplifying the visualization of complex mesh networks or multi-region architectures. Positioned as a specialized layer of network insights, Connection Monitor empowers Azure administrators to proactively spot problems and reduce downtime, thereby bolstering the reliability of critical cloud-based services and applications. Setting up Connection Monitor requires specifying test groups, which define the sources, destinations, test frequency, and protocols. Administrators often designate multiple endpoints to collect broader visibility into cross-region operations, especially in geographically distributed environments. Test endpoints can refer to virtual machines, IP addresses, FQDNs, or URLs, enabling a wide range of use cases, from verifying internal application connectivity to monitoring external APIs. Configuration is carried out through the Azure portal or scripting tools such as PowerShell and Azure CLI, allowing for automation and integration with infrastructure as code pipelines. Once created, Connection Monitor continuously performs the specified tests and aggregates the results into easily interpretable dashboards. Administrators can further leverage filtering capabilities to pinpoint anomalies per region or per endpoint. By systematically defining test criteria and measurement frequencies, Connection Monitor delivers actionable data that fosters an informed approach to capacity planning and ongoing operational resilience. When Connection Monitor completes each test, it aggregates results into a dataset that can be reviewed in near real time through the Azure portal. This data can also be routed to log analytics for advanced querying and long-term retention. Metrics typically include latency, packet loss, and protocol status, with visual charts simplifying trend detection. Administrators can set up alerts based on thresholds, ensuring that support teams receive notifications when performance dips below acceptable levels. By filtering data according to region or resource group, operations teams can rapidly identify localized issues before they escalate. Additionally, tags can help categorize connections by application or environment, providing further flexibility. Correlating Connection Monitor data with other telemetry, such as VM performance metrics or Azure Monitor logs, enables holistic root cause analysis. By examining the context around performance deviations, network engineers can implement remediation strategies more effectively. Connection Monitor and Network Watcher integrate with various Azure services to create a comprehensive monitoring ecosystem. For instance, routing diagnostic data to Azure Monitor logs enables the use of Kusto Query Language, KQL, for advanced analytics, such as identifying recurring connectivity issues across multiple regions. Coupled with Azure Alert Rules and Action Groups, logging data can trigger automated remediation actions or notifications to specified channels like email, Azure mobile app, or integrated chat tools. Integration with Azure Resource Graph further augments visibility by allowing organization-wide queries, even if resources span multiple subscriptions or Azure Active Directory tenants. By placing Connection Monitor logs in Azure storage, businesses can maintain secure, long-term archival and comply with data retention standards. This connectivity among Azure services ensures that the insights gleaned from Network Watcher and Connection Monitor remain aligned with broader operational intelligence and governance strategies. After data is collected and analyzed from Network Watcher and Connection Monitor, administrators can make informed decisions to refine network architectures. Identifying high-latency paths can prompt the addition of express route connections or the reconfiguration of peering arrangements to reduce hops. Analyzing packet loss patterns may reveal misaligned NSG rules or potential bandwidth constraints. In these cases, revisiting virtual machine sizing, adjusting load balancer configurations, or enabling accelerated networking can enhance throughput. The metrics also help refine policies, such as adjusting congestion control mechanisms to meet specific workload demands. Meanwhile, insights gleaned from aggregated test data across multiple regions highlight where content delivery networks, CDNs, or additional availability zones might reduce latency. By systematically leveraging the feedback loop provided by Network Watcher, Connection Monitor, and Azure Monitor, organizations can cultivate a proactive stance on network health, optimizing performance before issues disrupt critical services. Network Watcher and Connection Monitor excel in helping administrators quickly isolate the root causes of network disruptions. By leveraging tools like IP Flow Verify, teams can determine whether specific traffic flows are blocked by misconfigured NSGs or unexpected firewall rules. Packet capture adds another layer of detail, enabling deep inspection of the data plane when diagnosing intermittent issues or undocumented application behaviors. Connection Monitor's synthetic testing offers a continuous baseline against which anomalies are measured, expediting recognition of service degradation. In hybrid scenarios, data from these tools can be correlated with on-premises logs or third-party solutions, forming a comprehensive view of cross-boundary traffic. Administrators can compare flow logs and performance counters to rule out resource-level constraints or operating system misconfigurations. By using Azure Monitor queries, teams can rapidly trace error patterns across entire multi-region environments. This unified approach ensures thorough investigations supported by consistent, real-time network intelligence. Network Watcher and Connection Monitor play a key role in reinforcing security across Azure deployments. NSG flow logs provide detailed records of accepted and denied traffic, enabling in-depth forensics when unusual or unauthorized connectivity is detected. Administrators can set queries to detect patterns like repeated failed connections or unconventional port usage, aligning with least privilege requirements. Packet captures aid compliance efforts by validating that only sanctioned data flows are permitted, assisting with standards such as PCI DSS or HIPAA. By continually testing connections, organizations can verify the resiliency of encryption protocols such as TLS for sensitive data transfers. All logs generated through Network Watcher and Connection Monitor can be retained in secure storage, audited, and analyzed for regulatory compliance. In high-security environments, integration with Azure Sentinel provides further capabilities like threat detection and incident response. These combined measures uphold both the functional and regulatory needs of modern cloud deployments. Effective network monitoring strategies leverage multiple data sources to build a comprehensive view of environment health. Periodic checks, through scheduled packet captures or automated connection monitor tests, ensure organizations accumulate enough data to identify trends and anomalies. Proactive alerts should be configured at thresholds aligned with performance and security requirements, such as maximum allowable latency or strict rules for inbound traffic. Administrators benefit from labeling resources with clear naming conventions and tags, making data analysis straightforward. Centralized logging in Azure Monitor and well-structured queries in Log Analytics streamline investigations and historical comparisons. It is advisable to implement role-based access control, RBAC, strictly to manage who can run diagnostic tasks, protecting both performance and security. Furthermore, using automation tools and templates helps maintain consistency across regions and environments. By systematically applying these best practices, organizations remain ready to identify and respond to network events effectively. Azure Network Watcher and Connection Monitor continue to evolve, with new features aimed at deeper analytics and simplified workflows. Emerging enhancements may leverage machine learning to predict potential issues, automatically adjusting rules or initiating alerts. Integration with Azure Arc could expand the scope of these monitoring tools beyond Azure, encompassing on-premises and multi-cloud architectures. For day-to-day support, learning resources include official Microsoft documentation, tutorials, and hands-on labs that walk through typical deployment scenarios. Administrators can also explore sample queries to derive advanced insights from flow logs and performance metrics. Engaging with the Azure community via forums or user groups is recommended for sharing best practices, troubleshooting tips, and success stories. By staying current on release notes and previews, professionals can harness the latest capabilities of these services, ensuring that network visibility and reliability remain first-class goals across all Azure-based solutions.